Yeah, so let's start second lecture of MAT-101. Actually, we will see the syllabus of second paper, that is MAT-102 in this lecture. So let us see what is syllabus of MAT-102. So in last lecture, we have seen syllabus of first paper, that is MAT-101, differential calculus. So let us see the syllabus of second paper, that is MAT-102. So yeah. So yesterday, first we have seen the structure of BSc course. What is actual mathematics papers situation in your course, 3-year course? Actually, there are 16 papers. So there are total 6 semesters. First year, so there are 2 semesters, and at each semester there are 2 mathematics papers. In second year, again there are 2 semesters. Each semester have 3 mathematics papers, and in third year there will be again 2 semesters, and each semester will have 3 mathematics papers. So total there are 16 mathematics papers for this BSc course. So out of that, for first semester, so there are 2 mathematics papers, first MAT-101 and second MAT-102. So in last lecture, so already we have seen the syllabus of MAT-101, that is differential calculus. So actually there are total 7 chapters. Out of that 7 chapters, first 5 chapters are from differential calculus, and remaining 2 chapters are from vector calculus. So in this lecture, we'll see what is the actual syllabus of MAT-102. So MAT-102, it is differential equations. Let us see. So there are total 7 chapters. So chapter first. What is chapter first? See. So chapter 1. Yeah. So chapter 1, as usual, it is prerequisite. Prerequisite means, so this is introductory chapter. So in that you'll see, so in first chapter, you will see ordinary and partial differential equations, means you will see definition of partial differential equation and ordinary differential equation. So ordinary and partial differential equations. Then you'll see order and degree of differential equation. Differential equations. So after that you will see solutions. So what is solution of differential equation? So differential equation will be of two types. It may be it will be ordinary differential equation or partial differential equation. So what will be solution of ordinary differential equation and what will be solution of partial differential equation? So it will be totally different. So in solution, we will see general solution. What is general solution of differential equation? Then you will see particular solution, and then singular solution. So these are 3 types of solution. So this is chapter first. So in first chapter, you will see ordinary and partial differential equations, order and degree of differential equations, solution. So in solution, you will see 3 types of solution: general solution, particular solution, and singular solution. So This is chapter first. Chapter 2. So title of chapter 2 is equations of first order and first degree. Equations of first order and of the first degree. So in first chapter, we'll study only differential equations of first order and first degree actually. So the title of this course is differential equations. In this course, we'll just study ordinary differential equations. So there is one chapter, that is chapter 7. It will contain just introduction to partial differential equation. So this course, maximum part of this course depends on ordinary differential equation. Yeah. So in second chapter we'll study only ordinary differential equation. So title of second chapter is equations, means differential equations, and in particular ordinary differential equations of first order and first degree. See, so in that you'll see exact differential equations, exact differential equations, then you'll see linear equations, then equations reducible to the linear form. So we'll see three types of first order and first degree differential equations. First, that is exact differential equation. Second, linear equations, and third, equations reducible to linear form. So this is chapter second. Next, what is chapter 3? Third chapter. See, title of third chapter is linear equations with constant coefficients. Linear equations with constant coefficients. So this is third chapter. So in third chapter you will see. So we'll study linear equations, then complementary functions, particular integral, then complete integral, after that you'll see the linear equations with constant coefficients, the linear equations with constant coefficients, and second numbers 0 and second number 0. Next we'll see auxiliary equations having equal roots, auxiliary equations having equal roots. Then you'll see case of auxiliary equations having imaginary roots, case of auxiliary equation case of auxiliary equation having imaginary roots, then you'll see the symbol D. Yeah, the symbol D. What is meaning of symbol D? Then linear equations with constant coefficients. The linear equations with constant coefficients having, yeah, the linear equations with constant coefficients and second member as a function, and second member a function of x, just function of x. Then you'll see this symbolic function this symbolic function हेलो, हाँ बोला ना, ठीक है ठीक है ठीक है चल. So next, the symbolic function 1 upon e of t. Next, method of finding particular integral. The method of finding particular integral. So after that, you will see short methods of finding particular integrals. Short methods of finding particular integral. Integrals corresponding to the terms corresponding to the terms. First, it is e raised to x, then x raised to m, then sin x, cos x, then e raised to x into v, and last, that is x into v. So capital V is another function of x in the second member. So this is chapter number 3. So what you will see in chapter number 3. So title of chapter 3 is linear equations with constant coefficients. See. So in that we will say linear equations, complementary functions, particular integral, complete integral, the linear equations with constant coefficients, and second number 0, auxiliary equations having equal roots. Case of auxiliary equations having imaginary roots, the symbol t, the linear equations with constant coefficients, and second member a function of x. The symbolic function 1 upon e of d, actually it is integral. The symbolic function operator 1 upon e of d. So it is 1 upon e of d. So it is inverse differential operator. So it will be integral operator. The method of finding particular integral, short methods of finding particular integrals corresponding to the terms e raised to x, x raised to m, sin x, cos x, e raised to x into v, and last x into v in the second member. So this is chapter number 3, and this chapter 3 contains more than 40% syllabus of this course. So this is main chapter of this course. So next chapter, that is chapter 4. See, so chapter number 4 is linear equations with variable coefficients. Linear equations with variable coefficients. So in this chapter, we'll see first the homogeneous linear equation. The homogeneous linear equation. Then methods of finding solution. Methods of finding solution. After that, the symbolic functions. Symbolic functions. First, 1 upon f theta. So it is operator. And second, 1 upon f dash theta. So these two operators, symbolic functions, 1 upon f theta and 1 upon f dash of theta. Next, methods of finding particular integral. Methods of finding particular integral. Integrals corresponding to term. Next, integral corresponding to a term of the form x raised to m in the second member. Next, equations reducible to homogeneous linear form. So this last topic, equations reducible to homogeneous linear form. So this is chapter number 4. So in chapter 4, you'll see homogeneous linear equations, methods of finding solution, the symbolic functions, 1 upon f theta and 1 upon f dash theta, methods of finding particular integral, integrals corresponding to a term of the form x raised to m in the second member, and last, that is equations reducible to homogeneous linear form. So this is chapter number 4, linear equations with variable coefficients. So next, that is chapter 5. So title of chapter 5. Chapter number 5. See, exact differential equations and equations of particular forms. Exact differential equations and equations of particular forms. And equations of particular forms. So what we will see in this chapter. So let's see the topics included in chapter number 5. So first, exact differential equations. So these are higher order differential equations. So exact differential equations Then criteria of an exact differential equation. Criterion of exact differential equation. The integration of an exact equation. The integration of an exact equation. Next, equations of the form. So these are particular forms of exact differential equations. So next, equations of the form first dny by dx raised to n equal to fx, that is n derivative of y with respect to x is equal to fx. Equations of the form second, the equations of the form d square y by dx square, d raised to n y by dx raised to n equal to f of y. So this is second form. So chapter number 5, it contains nth order differential equations. So in that you'll see exact differential equations, criteria of exact differential equation, the integration of an exact equation, equations of the form. So n derivative of y is equal to fx and the n derivative of y equal to f of y. So it is function of x and it is function of y. So next chapter, that is chapter number 6. So what is chapter 6? So title of chapter number 6 is ordinary differential equations with more than two variables. Ordinary differential equations with more than two variables. So in chapter number 1 to 5, we have seen ordinary differential equations of single variable. So in chapter number 6, we will see ordinary differential equations with more than two variables. So in chapter number 6, we will see. So this is chapter number 6. So we will see simultaneous differential equations. Simultaneous differential equations. Then simultaneous equations of first order. Simultaneous differential equations of first order. So this is just chapter number 6, which is short. And next chapter, that is chapter number 7, which is the last chapter. Chapter number 7, partial differential equations. Partial differential equations. So this is different chapter, which contains partial differential equations. In chapter number 1 to 6, we study only ordinary differential equations. In chapter 7, we'll study partial differential equations. So which topics we'll study in chapter number 7? See, we'll write first definitions. Actually, these are definitions of partial differential equations, order of partial differential equation, similarly degree of partial differential equation, and like this. Next, derivation of partial differential equation by elimination of constants. Second, derivation of partial differential equation by elimination of constants, that is first type, and then derivation of partial differential equation by eliminating arbitrary functions. Second, derivation of partial differential equation by elimination of arbitrary functions. So this is chapter number 7. It, it contains just introduction to partial differential equations. So in that you'll see definition of partial differential equation and then how to derive partial differential equations by eliminating constants. And then second type, that is the derivation of partial differential equation by eliminating arbitrary functions. So this is about syllabus of this course, that is MAT-102 differential equations. So what are the recommended textbooks by university? So we'll see the recommended textbook by university. Textbook recommended by university. See, so there is only one book, and that is Introductory Course on in Differential Equations. Title of this book is Introductory Course in Differential Equations. So this title of this book, and its author is by D.A. Murray, Daniel Murray. D.A. Murray. And its publication is Khosla Publishing House, New Delhi. Actually, it is Indian edition. So author, and its publication is Khosla Publishing House, New Delhi. And its edition is 2003. So there are different editions of this book. So recently 2019 edition is also there. So there may be some changes. So the textbook recommended by university for this course is Introductory Course in Differential Equation by Daniel Murray, and its edition of 2003. Yeah. So this is about syllabus of MAT-101, that is differential equations. So we'll start one of the, we'll start MAT-102 or MAT-101, anyone, course of these two. So we'll start second course, that is MAT-102. So next I will continue second course, that is MAT-102 differential equations. So So next we will see first chapter of MAT-102. So we'll continue. MAT-102, it is differential equations. So this is title of this course. So we'll start first chapter of this course. It is so chapter first, and it is just a minute. Yeah. Chapter first, it is prerequisite. Yeah. So for chapter that is prerequisite, let's see. So first we'll see definition of differential equation. What is differential equation? So title of this course is differential equations. So naturally, first we will define what is differential equation. See, so first differential equation. What is differential equation? Definition. So already you have seen. So derivative. What is called derivative? What is differentiation? So this word differential comes from derivative or differentiation. So what is derivative? If suppose y is a function of x, let us see. If y is a function of x, then you can differentiate y with respect to x. So what is dy by dx? So dy by dx will be y dash of x. You denote it by y dash of x. So this dy by dx is a differential operator. So it is called, see, it is differential operator. See, so what is differential equation? So before that, what is equation? See, equation means, what is equation? So already have seen, so linear equations with two variables, solution of linear equations with two variables, three variables, four variables. You have seen different methods also. So what is equation? If you are equating something with respect to something with some known quantity or fixed quantity. Let's see. So what is equation? Suppose if we consider Suppose x equal to or 2x equal to suppose 10. This is equation. I'm equating 2x equal to 10. Let us see. So 10 is fixed quantity. Here 2x is variable quantity. So x is variable. So 2x is variable. So that will imply, let us see. Suppose x equal to 5. What is the meaning of x equal to 5? X equal to 5. You are equating something with something. So that is equation. So in equation, already have seen different variables. So equation contains equality, variables, and some constants. Let us see. So what is differential equation? A equation which contains this differential operator. So this is first order differential operator. Similarly, if you differentiate dy by dx with respect to x again, so you'll get d square y by dx square, and it is y double dash x. You already seen this. So this is second order differential operator. So this is first order. See, it is first order differential operator. If you differentiate this first order differential operator again, you'll get a second order differential operator. It is second order differential operator. See, in similar way, if you differentiate this n times, so you get n differential operator, and that is n derivative of y with respect to x. So this is nth order differential operator. See, what is differential equation? See, a equation which contains this differential operator means it may be first order, second order, third order, fourth order, or nth order. A differential equation which contains just differential operators is called differential equation. See, so I'll write definition of differential equation. So I will erase all these things. It's just rough work I've done here. So it is not necessary to write in your notebook. Rough work I'm writing cross direction. So be careful. So don't write these rough things. So what is the definition of differential equation? An equation involving derivative. Let us see. An equation involving derivative or differentials of one or more dependent variable of one or more dependent variables with respect to one or more independent variables with respect to one or more independent variables is called differential equation. So it will be basic definition of differential equation. What is differential equation? An equation involving derivative or differentials of one or more dependent variables with respect to one or more independent variables is called differential equation. So question comes another, and it is, what is dependent variable and what is independent variable? See, for example, just a written. See, so y is a function of x. See, so here y depends on x, and I will write it as suppose x square plus 5. So suppose y equal to x square plus 5. So y is a function of x. So which is the dependent variable and which is independent variable? Let us see. So here this y depends on x. As x varies, y varies. So y, it is dependent variable. See, and this x will be independent variable. So what is dependent variable and what is independent variable? So y depends on x, and hence it is called dependent variable. X and y depends on x, but x does not depends on any variable, so therefore x is called independent variable. See, if we differentiate dependent variable with respect to independent variable, so this process is differentiation. See, so there may be one or more independent variables, and similarly more than one dependent variable. So for example, if y is a function of, suppose you can write x and t, let us say, so it will be x square plus t square, suppose. So here y depends on two independent variables, so these are independent variables, and y is dependent variable. See, so y depends on two independent variables. So in that case, if you differentiate y with respect to these independent variables, so first you have to differentiate with respect to first independent variable x, and then second independent variable t. So in that process, so that differentiation will be partial differentiation. So there will be sharing of differentiation. So first you are differentiating with respect to x, and then you are differentiating with respect to t. So in that case, it will be dou y by dou x, and second it will be dou y by dou t. So there will be two differentiations, and these are called partial differential. Let us see. What is differential equation? It may contains ordinary. So let us see. This is ordinary differentiation or ordinary derivative. If we write dy by dx, if y is a function of x only, if there is only one independent variable, then the derivative is, so dy by dx, in that case it is ordinary derivative. See, but if there are more than one independent variable, then in that case these derivatives will be partial derivatives. So this will be partial differentials or partial derivatives. See, so the difference is there. Already you know all these things, so I will not repeat all these things in details. So continue. So next, what are the examples of, let us see, what are the examples of next examples of differential equation. So first I will write dy is equal to, suppose, x plus sine x into dx. It will be an example of differential equation because it contains derivative. It contains differential. Second, see, so for derivative of y with respect to x, plus I will write second order derivative of y with respect to x, and plus I will write dy by dx, its power 5, and that is equal to, suppose, e raised to x. So that will be another example of the differential equation. Similarly, we will write, see, so yeah, dou square u by dou x square plus, suppose, dou square u by dou y square equal to, suppose, see, 0. That will be another example of partial. It will be example of differential equation, and it is partial differential equation. See, fourth I will write, suppose, so dy by dx into dou by dou x plus, suppose I will write it as, so dou z by dou t into dy by dx, and that is equal to 0. That will be another example of a differential equation, and likewise. So next definition. Yeah, I will stop here. So